All right, so let us begin. Good evening, everyone. Once again, I'm Sweta Chatterjee, a PGT physics teacher at a school in Kolkata, and currently I'm pursuing my Masters of Education from the International Teachers University. So today's topic is enhancing physics teaching with AI, transforming the classroom with smart tools and interactive learning. This is a brief thing about me. I completed my bachelor's in physics and went on to pursue my master's in instrumentation science, where I was fortunate enough to receive a gold medal. My academic journey has always been rooted strongly in both physical uh, science, conceptual physics, and applied science. I've been teaching physics for over 8 years across CBSE, ICSE, and ISC curriculum. And currently, I'm teaching in the international curriculum, including IGCSE and IB. I've also taught mathematics at the secondary level, which has helped me integrate analytical thinking into my physics teaching. And beyond the classroom, I served as a state level evaluator for the National Children's Science Congress multiple times, which has deepened my engagement with student led research and inquiry. On a personal note, besides academics, I'm a trained Bharatanatyam dancer and a singer as well. I truly believe creativity and science go hand in hand. I enjoy experimenting with new technical tools, especially technology, to make physics more engaging and meaningful. And that curiosity is what brings us to today's session. Hope you will have a nice evening. So, quickly moving on to the learning objectives. By the end of this masterclass, you won't just know about AI tools, but you will know how to use them meaningfully and confidently in your physics classroom. So we'll begin by identifying few AI tools, then understand how they help visualize the abstract concepts. After that you will see how these tools can be applied to create classroom activities. And moving on to some higher level thinking, we'll analyze how AI impacts engagement and differentiation. And finally, I'm sure all of you will be able to design a simple AI integrated physics learning task of your own for your students. So today's takeaways, even after the end of the session, if you do not remember anything, just remember these. I want you to carry these. Firstly, AI helps us make abstract physics concepts more visible and interactive for students. Secondly, when used with purpose, AI can increase engagement and support differentiated learning. And thirdly, AI is not here to replace teachers. It is just a tool that strengthens effective teaching. So let us begin with today's icebreaker. All of you, please take out your phones and scan the QR code on the screen. You will see two quick questions and tell us, as teachers, which physics topic do students struggle with the most? In one word. And why is it difficult? Let's see what pattern emerges. Don't overthink, just your first instinct. Some words are already there. Interesting. I can see some patterns forming. Three. I know it's a Saturday evening. Your brain might already be in a weekend mode. Okay. Yes, I can see motion. Anyone else? I promise I won't judge your physics memory. Just a few options. Okay, moving on to the next slide. As why they think it is difficult. Um, It requires still voting. Abstract, definitely invisible. Yes, the only subject in science that there are so many things that are invisible. People cannot directly observe, especially magnetism, magnetic fields, 3D, three dimensions, four dimensions, so many things. So 50% think people it's abstract, and 50% think people think it's invisible. Okay. But there are many students who have phobia for maths and they love physics a lot, and they're like, no, ma'am, we don't want to pursue physics because there are too many mathematics in them. So mathematical is definitely a part of physics. All right. So let's move on to the slide. Let's quickly watch a video. So we have got interesting words, definitely. These responses tell us something important, that students struggle with physics because it is impossible. I mean, sorry, not because it is impossible, but there are many things which cannot be visualized, right? So if the technology, the intelligent technology, especially AI, begins to play a powerful role, why not use it? So, when we think about reinvigorating physics education, it is not about replacing AI or replacing traditional teaching, it's about enhancing it. So, just watch the video.
Imagine a world where physics education and research don't just keep up with technological innovation, but fuel it. Where the integration of AI and machine learning isn't just an option, but a transformative force for learning, discovery, and advancement. The question is, how do we make this vision real? We start by harnessing AI and ML to create personalized, dynamic learning experiences that adapt to each student's unique pace and style, empowering them to learn deeply and think critically. But let's be clear, this journey demands active engagement. If students settle for shortcuts, copying answers, or skipping the hard work, they'll miss out on the incredible potential these tools can unlock. AI and technology move rapidly, often faster than traditional education can keep pace. So, to truly thrive, students must dive deep, mastering the fundamentals that underlie every principle of physics. This isn't just about staying relevant, it's about becoming irreplaceable. And that means going beyond classroom walls, taking on projects that challenge the mind, and stepping into the emerging fields where the future is being built. This is our moment to elevate physics education, to inspire action, and to shape a generation ready to innovate and lead. Let's take that step forward and make it happen. Imagine a world...
Thank you. Thank you. So I hope as all of you watch this video, I'm sure you must have reflected on this one question, how AI can transform the way we teach and research physics, isn't it? So AI gives us new ways to visualize the invisible, to personalize explanations, to provide real-time feedback, and to encourage inquiry-driven exploration. So let us now see why we are talking about AI. See, as we just saw, AI is no longer a futuristic idea. It is a practical and accessible tool for educators today. For teachers, AI can reduce time spent on routine tasks like generating questions, analyzing responses, creating differentiated materials. So these gives us more time for meaningful and hands-on and conceptual learning. Then for students, AI connects learning to the digital world they already engage with. It makes learning interactive, responsive, and relevant. And in physics, especially, AI supports inquiry based exploration, helping students visualize complex phenomena and move from memorizing formulas to truly understanding concepts. Yes. But while traditional teaching has its strengths, it also presents some challenges. We definitely are still doing the traditional teaching, but let us see some of the challenges. Firstly, passive learning. Now, classrooms often rely on one-way communication. The teacher explains, students listen and take notes. This can definitely reduce engagement, and many students, the Gen Z, Gen Alpha students, they struggle to stay focused, be patient, and deeply involved. Secondly, limited opportunities for experimentation. Physics is an experimental science, we all know that. So, without hands on exploration, students find it difficult to connect theory with a real world application. Third, there is lack of personalization sometimes. Every student learns at a different pace and in a different way. We know that they have different unique learning styles. So traditional method follow a single approach which may not address individual needs. And final one, there's no immediate feedback. Students may only discover misunderstandings after a test or an assignment rather than correcting them in that very moment. It is not always possible for us teachers dealing with more than 30 students in a class, and within that class of 45 minutes, it is really difficult for us teachers to provide a real time feedback. So, if we use these tools which can do the job for us, then why not? Thank you for the reactions. Okay, so let us see how AI-based solutions are used in physics. Again, so if traditional methods present challenges, let's see how AI respond. Hands-on experiments, interactive simulations. So students can manipulate the variables, they can test the hypothesis, observe the results instantly. We would do one by one. Concepts like friction, wave interference becomes visible and dynamic rather than abstract. Then next we have adaptive learning application tools. AI can adjust difficulty levels, generate personalized practice questions, then identify the misconceptions based on the student's response, right? So learning becomes individualized instead of that thing that one size fits all. Thirdly, there is data analysis and visualization. The graphs, everything is generated, filled patterns, motion analysis. So the complex data sets or the trends, everything can be visualized and they can connect somehow the students. They can connect the mathematics with the physical meaning. And the last but not the least, there are now currently so many AI driven assistants who provide instant feedback, then step to step explanations, and even differentiated examples. So, almost like a 24 into 7 physics mentor. So, they are there with the students. So, somehow, AI shifts physics from passive listening to active exploration, I believe. So, quickly, if you're not getting bored, quickly type this in the chat. Students understand physics better when they can. Let us see what all responses we get. Think like you are students for a moment. Again, so many participants. Just a small word in the chat box. Students understand physics when they can. If your brain is saying weekend, just type the first word that comes to your mind. Anyone? Do you think visualize would be an option? Connect? No overthinking. Let's see what ideas emerges. Experiment. Okay. When students can question or explore. I thought of these words. So I think these are some of the words students can understand physics when they see, when they experiment, when they apply or question or explore, right? So these are exactly the elements AI powered tools can strengthen in our classroom. Yes, visualize. Thank you, Harsha. So let us move on to our next slide and let us get introduced to some of the AI tools one by one. So the first one is making the visible invisible. So I'll quickly take you to this simulation. I'm sure all the physics teachers are in love with this visual support. Yes, thank you. Thank you, Mark. PhET is a very popular simulation app that all of us use. So let's look at our first AI supported tool category. I chose interactive simulations, and the first thing that came to my mind is PhET. So students often, I chose this part, topic friction, because students often read in textbooks that static friction is a self-adjusting force. I'm talking about class grade 9, 10, 11, these students. We know that there are three types of friction: static friction, rolling friction, sliding friction. And that static friction is a self-adjusting force. They memorize the statement, but they don't really understand what it means. So if we can show them that suppose there is a box and this person has to apply a force. So let us see, he applies 1 Newton, the, the box doesn't move. Then we can increase it. So see, as you can see the arrow, teachers, you on one side there is the applied force and on the second side there is a frictional force. We increase it more. Do you see the change? The red arrow on the left increased. So that means now that the applied force is 102 newtons, the frictional force is also 102 newton. That means the frictional force increases with increase in the applied force. It is not a constant quantity. That okay, the frictional force is 50 Newton. That means the moment you apply a force greater than 50, the box will start moving. No. As we increase the applied force, the frictional force also increases. Let us increase it further and see when does it start moving. See, both the arrows are becoming bigger. 115. I think now 125. So these simulations basically help the children to understand that what do you observe as I increase the force? What do all of you observed? That it self-adjusts. It increases to a maximum value and then the box started moving. So these things cannot be physically seen in a real classroom experiment or when you're teaching it using the traditional methods like the lecture methods. Also, one thing, what did you all see? The friction suddenly decreased. The arrow slightly decreased as the motion started, which also means that the moving friction or the kinetic friction is less than the static friction, right? All right. So with this, these are some things that we learn from these simulations. So why do these PhET simulations are powerful? Firstly, they make the abstract concepts visible. Students can see the forces adjusting in the real time. Encourages active learning. So students are not just watching, they are also manipulating variables. They are actively involved. Then there is the immediate cause effect understanding that you change one variable and you observe the result instantly. And finally, it promotes inquiry based learning, the allowing the students to predict what's going to happen, to test, and definitely to refine their thinking. Hope all of you enjoyed this. fed simulation, and I would ask all of you to go through it, explore the site, and there are a lot of simulations that you can apply to your real classroom. Density lab, motion, waves, optics, so many topics are there, teachers. Okay, another activity for you. Type one concept you wish students could see. It's your turn now. I showed a simulation. Just one word or a phrase. Yes, Dina, FET is really a very good app. I'm in love with it. Flow of charge, absolutely. Optics, correct. Electric fields, I would say. Then sometimes magnetic flux, waves, interference of waves, energy, current. Oh, lovely. Thank you so much. So, how many of these are abstract or invisible? All of these, Faraday's laws. Yes, thank you. And this is exactly why AI powered visualization tools can transform the understanding. So many. Some of Mark said electric current. Yes. So suppose we use a virtual lab before taking the students to the real lab. So don't you think it helps them? They already have an understanding of what is going to happen, and they visualize things, and that can help them. So with this, I move on to my next AI tool, virtual physics lab. A quick uh, video for you. So already we have seen how simulations make concepts visible. So what about the virtual labs? Definitely LabStar is one thing. There are many other physics labs, then Amrita Lab, so many apps are there. So they actually create a story-based learning environment where students don't just observe, they experiment. They can visualize the abstract ideas, as one of you said, magnetic fields, then dangerous experiments sometimes can also be done safely, and they can receive guided support because Labstar has an AI lab assistant. So let's see what a short video on how this works in practice.
Labster is designed by scientists and combines content from in-house subject matter experts with interactive learning strategies and student success metrics to empower educators to engage today's learners in completely new ways. Our complete science learning platforms include hundreds of realistic lab simulations, supplemental resources, and customizable quizzes that fit right in with your existing course plan. Labster can be used by any student, anywhere, as preparation for in-person labs or activities, as homework, or as a fully online lab experience. Simulations are automatically graded, accessible, and easily integrated into learning management systems. Plus, dashboards track student progress at the course or department level, providing a clear overview of how students are performing and where they need the most support. Drive foundational learning, improve student pass rates, and ignite a passion for future STEM careers with the Labster Learning Advantage. Get started today. Labster.
Thank you for that. So, see, it can be integrated into the learning management systems. Then we can track the student progress. So, what makes virtual labs powerful is the combination of immersion as well as intelligence. So, students receive the step by step AI guidance, adaptive support, instant feedback. I saw there's a built in assessment system as well. And for teachers, see how the works becomes easier. There is an automated grading system, the dashboard, the curriculum alignment, and LMS integration. So, of course, these things save our valuable time. So, virtual labs can prepare students before you take them to the physical labs. So, that will reinforce learning afterward, or even serve as a standalone experience somewhere where resources are limited. In short, I believe they transform the passive learning into active inquiry based exploration while making teaching more efficient. So with this, I present to you a comparison chart. The physics lab, the normal physical lab, and the virtual lab, which is AI enabled. Obviously, both serve different strengths. Physical labs definitely provide real world tactile experience. I agree with some of you if you think that they need to touch, they need to see for in real. Definitely that is required. But I would agree. I would say that virtual labs enhance safety, reputation, and visualization, especially for abstract or high risk experiments. So, and sometimes they offer these feedback and greater accessibility. So learning becomes more flexible and inclusive. All right. Now there is again another activity for you. So a poll will be coming up on your screen. Let's hear your perspective. I'm launching a quick Zoom poll. Which approach do you think is more effective for conceptual clarity? Is it physical lab? Is it virtual lab? Or is it hybrid mode? All of you, please see there's uh, yes, some of you are texting in the chat. Thank you for your answers. Surely, Chandralekha, I'll definitely give you the details. Virtual hybrid, Ashish. Thank you, sir. Thank you. Quickly, just select one option that comes on your screen. Interesting. Thank you for your response. Yes, hybrid. Thank you, Anjan. Nasreen C. Yes, absolutely. So that's exactly the point I want you all to carry with you. It's not about choosing one over the other. Research increasingly suggests that a hybrid approach, which is combining physical experimentation with AI supported visualization and feedback, offers the strongest conceptual understanding. So the goal is not replacement, it's integration. So together, I believe they create a more powerful physics learning ecosystem. Thank you. So let us now move on to our third AI tool category, and it is lesson design and assessment, a very popular app called QueryPod. I wanted to share with you if some of you do not know about this, so I'll definitely share the details. This is how the home screen looks like. QueryPod transforms a regular physics lesson to an interactive experience. I can sure all of you can see for yourself what are the different options that you can do. Instead of passive note taking, students can respond live through polls, word clouds, and open-ended questions as well. It allows a teacher to instantly see their thinking, address the misconception, and most importantly, it promotes active participation and real time formative assessment also, where the schools focus a lot. So now instead of just explaining QReport, let me quickly show you how it works in the physics classroom. So I've created a very short interactive lesson on a very common misconception. So let us take you to there. Please, once again, a very small activity, and I think this is the last one. I promise I won't make you work longer and more. Just quickly scan this QR code. I'm giving you a few seconds, and it will take you to the QReport live learning lesson. All right. Thank you. I'll just quickly change the screen. Waiting for students to join. Oh, ready, but only one. Oh, so many. Thank you. Let's begin. Start. You have 1 minute, students, to quickly tell me what factors affect the falling speed of an object. Let's see. There's a word cloud which will form. Let's begin. Please write a word. I think you will see an option. Just write one word that you think that affects the falling speed of an object. Uh, Absolutely correct. Acceleration due to gravity. But if you can just write it in the app, it's a beautiful word cloud which forms. Okay, I'll move on to my next question. Sorry. Gravity, acceleration. I wish there were more words that would have formed beautiful things. So the teacher, already gets an understanding that what the class is thinking, what is their prior knowledge before I even start explaining. Okay, moving on to the next. 30 seconds, be faster, quickly, all of you. In vacuum, which falls faster? Start. Ready. A heavier object, a lighter object, or both? Cast your vote. Interesting. So these are sometimes when even the adults hesitate. So see, it will give me a quick instant formative assessment. Oh, thank you. We are after all physics teachers. Yeah. So if many choose the wrong option, suppose in a class you conduct this and few students choose the wrong option, then you exactly know that you have to address that concept immediately. Fine. And the last one. This is an open-ended question, teachers. You can just write a word or one activity. Ready, set, go. Why do students think that heavier objects fall faster? Obviously, in vacuum, I'm talking about. Just imagine you're a student again. So, what would you say? Oh, I've got many words. Just wait for a few more seconds. 14 words have already come up. So, shall I end the activity? Or just a matter of 10 seconds? All right. There's somebody replying in the chat as well. I think ma'am could not earth pulls heavier objects. Yes, ma'am, but in vacuum, uh, the students sometimes I think that the stone falls faster. You vacuum both of them because mass is not a factor. Yes. And 14. Force of gravity will be greater on heavier. Thank you. Absolutely. Concept of buoyancy, mass, and gravity. because they haven't observed vacuum. Correct. Thank you so much. So there are some videos in YouTube's also where you can actually show there are two conditions set. Initially there is air inside a chamber and you drop the two objects. You see, of course, the ball falling faster. Then you use a vacuum pump to create that vacuum in a lab, and then you would show that again. I used to do that with the secondary, middle school children. Yeah. Lovely, lovely. So let's go back to our PPT. So you see, just in 3 slides, I was able to activate prior knowledge, then assess your understanding, I mean, the student's understanding, and identify misconceptions, all in real time. I think it took us just 5 minutes, if not more. That's the power of AI supported interactive tools like CuriePod in a physics classroom. So it supports teaching, I think, in these four powerful ways. If more can be there. Number one, AI created interactive lessons can be generated, saving time while keeping content engaging. Then the real-time student engagement through these word clouds, the polls, the drawings, reflections. That's very interesting for them. And it provides instant formative assessment. We can understand, as I already said, the misconceptions, and immediately we don't have to wait for a test. And finally, it significantly reduces the planning time, giving teachers more space to focus on meaningful instructions, I believe. So now it's your turn, and the last one. I would like you all to create one short interactive slide in CuriePod for any physics topic of your own. It need not be a grade 10 physics topic, any grade, any level. It could be a misconception check. It could be a prediction question, a real life application prompt, whatever. Word cloud, poll, a drawing task. I think I showed you, what are all the things. So many things are there. See? Draw and vote. Or you can even have this Curie quiz is very interesting for science. Just think of one concept where students usually say, I don't get this. Start simple. Even one well-framed question is powerful. I'll give you 2 to 3 minutes of time. If you are stuck, begin with a misconception that you have already seen in a class. You don't have to be perfect, just purposeful. Perfection is not the goal, exploration is the goal. So I just want you to minimize this tab and just explore what all are there in CuriePod. Yes. How quickly AI help structure ideas. So now imagine the time saved in real lesson planning. All right. So, if you have actually explored it, even if for a few seconds, can you quickly tell me over chat? Just reflect for a moment and respond to two quick questions. How easy was it to generate interactive content? Or you can even answer the second one. How could this change your current teaching practice? Just a mental stretching before dinner today. Okay. I think you could not explore much today, so you can do that at home. It is amazing. I love CuriePod and its multiple uses. Oh, thank you. It's really easy. Yes, either import your original or use AI. Yeah. Absolutely. Thank you. Thank you so much for your responses. Okay. Thank you. And I think we are just left with one more AI tool uh, for this masterclass. And to the most popular one, Chat GPT, Edu Physics Assistant. So our final tool is this. It can all of you may say that it all does the thinking, so critical thinking is gone, but no, there are some special uses as well. It can deliver personalized conceptual explanations, adjusting language and depth based on a student level. If you give the proper prompt, it supports real-time question answers. Yes, helping clarify the misconceptions instantly during or after the class. So I've seen videos where students are learning on themselves, the flipped classroom method. Teachers can use it generate practice questions, differentiated tasks, or even extension problems within seconds. And uh, it can also help us the analyze how the students response, identifying the possible misconceptions or misunderstandings, and importantly, it promotes higher order thinking, generating application analysis prediction based questions rather than just recall. If you use it thoughtfully, it becomes not a replacement for the teachers. Please understand, it becomes a powerful academic support system. You might consider exploring it after the session, all of you. I'm not taking you through it because all of us are already accustomed to this. So after this session, please explore it. Even a single prompt like explain electromagnetic induction for grade 10 can open interesting possibilities. Just check. Perhaps, I'm sure after these masterclass, your next lesson plan could include a small AI assistant element just to see the difference. So with all these little tools, I've showed you 4 tools. This is just a comparison. What are these tools used for? PhET is best for visualizing abstract concepts, I believe. Labster, on the other hand, supports immersive experiment-based learning. And QueryPod enhances real-time engagement, formative assessment. It is very good for that. And ChatGPT Edu supports personalized explanations and higher order thinking. And the key is not choosing one, aligning with the right tool with the right learning goal. So teachers have to understand that. While preparing these masterclass teachers, I explored recent research on AI in science education. Uh, Myself visited and watched a lot of videos. Students show how AI enhanced tools, studies show that how these tools significantly improve students' understanding of complex scientific concepts. There are studies on this. I'm giving you the subside for that. This reinforces an important point. Technology alone is not transformative. It is the combination of sound teaching strategies and intelligent tools that leads to deeper conceptual learning. I think all of you would agree. But that takes us to the one very important question. Before we conclude, I want to acknowledge something important. Many teachers hesitate to use AI. I am recently some countries are even shifting back to pen and paper approaches because of concerns about over dependence on technology. I'm sure you all agree, and I also am aware of that. Are those and those concerns are definitely valid. AI is powerful, but it is not perfect. So there is a risk of over reliance where students allow AI to think for them. There are these ethical considerations, including academic integrity and data privacy. There are also accuracy issues. Sometimes AI can generate errors if not used critically. And I think teacher guidance is required. So the real question is, should we use AI? Or how should we use AI responsibly and pedagogically? So AI should enhance inquiry, not replace it. It should support thinking, not do the thinking. So when guided by strong teacher judgment and sound pedagogy, I think AI becomes a powerful ally. Without that guidance, it becomes just another tool. And that responsibility, that discretion remains with us. So we have to use it ethically. So as I conclude today's masterclass, let us return to the key ideas of this session. AI enhances, not replaces the physics teacher. So our jobs are not going to get over. Our expertise, judgment, human connection definitely remain central. AI improves visualization, support differentiation, as I said so many times, and it can increase student engagement. As I said, that today's children, they are very impatient. So they have to be, always we need to keep them engaged. So that is where AI helps us. Technology becomes truly powerful only when it is paired with strong pedagogy. Tools alone do not transform classrooms. Thoughtful teaching does. So, how you use it thoughtfully, that is the main idea. And if learning becomes interactive, then the conceptual understanding deepens. Students move from rote memorization to exploring ideas. Ultimately, the future classroom is not AI alone. It is a balanced integration of teacher expertise, intelligent tools, and active learners. So that balance is what will shape meaningful innovation in physics education. So just to revisit our learning objectives, I think I'm confident we have addressed each one. We identified few AI-powered tools that support physics teaching. We explored how these tools visualize complex and abstract concepts. We applied these tools through interactive demonstration and activities. We analyzed how AI can enhance learning, lesson planning, then assessment, differentiation, and through discussion, reflection, and hands on exploration, we have moved from understanding to thinking critically. So that's completes the journey we set out at the beginning of this masterclass. And just to pause and reflect on what we are taking with us. AI makes the invisible visible. So some concepts can be very easily explained, and AI doesn't just add technology, it enhances engagement and lesson delivery. And the third one, AI shifts classroom from passive note taking to active exploration. So please, teachers, do just remember one thing from today, and let it be this, that AI is not the star of the classroom. Learning is still. AI simply helps us making the learning deeper, clearer, and more interactive. As we come towards the end of the session, let me address few common questions that often come up when we talk about AI in education. No. The simple answer is no. AI can assist, but it cannot replace the professional judgment and the mentorship and the human connection. Yes, when guided thoughtfully, yes, it can enhance higher order reasoning when we use the prompt analysis and prediction. Differentiation, absolutely. It For struggling learners, it can simplify concepts, provide step-by-step guidance. For advanced learners, it can offer extension, tired activities, problems, higher order challenges. So it can create varied practice questions at different difficulty levels. These are some of the works cited. As educators, it is important that our practices are grounded in research. These references uh, informed both the design and pedagogical approach of this session. Please stay updated with us to stay connected with the ongoing professional development opportunities, the research updates, and the academic events. I encourage you to follow International Teachers University on Instagram. It's a great way to remain engaged with the learning community beyond today's session.